So today we will look into the graphing of the motion with the constant acceleration. So if we say that acceleration is constant, that means graph of the acceleration against time, acceleration time, and it will be horizontal line. Because it's constant, it does not change. Acceleration does not change over the time. Now, what the formula gives us relationship between velocity and acceleration? Yes? V equals u plus at. Final velocity equal initial plus acceleration times time. What type of graph that will be? What linear, but it's not horizontal. What will be gradient of this graph?
Constant.
Acceleration is a gradient. So if this, let's say, is u, initial velocity, that will be y-intercept. We have v against t, and we will have that acceleration is a gradient. So if velocity, initial velocity is negative, so it's moving in the negative direction initially. If it will be start from rest, if it will start from rest, then obviously graph will be like this, for example. Or if it starts from positive velocity, then it goes like this. Now, comparing green and black graphs. In which case, so let's say this will be 1, this is 1, this is graph number 2. In which case acceleration is bigger? 1. In one acceleration gradient bigger, it's accelerating. Now, what happens in the next graph? What happens in this graph?
It's going backwards.
Velocity, it's slowing down. This object slowing down until it momentarily stops. Then what happens in this point? Turn around. It's slowing down and then start accelerating in the negative direction. It's turn around at this point where velocity becomes 0. It turns around and accelerates in the opposite direction. Now, make sense? Any questions? So let's consider the next graph of the velocity against time. Velocity, time. So we'll have certain time, this is T1, that is T2, T3, this is T4, T5, and T6. What happens with the motion, how object moving during from 0 to T1? Yes.
As the increase acceleration, positive acceleration.
It's accelerating in the positive direction. What happens between T1 and T2?
Acceleration is constant.
Hmm?
Acceleration doesn't accelerate, it's 0.
It does not accelerate. It's moving with a constant velocity, gradient 0, moving with a constant velocity in positive direction. What happens between T2 and T3?
Slows down.
Slows down, and at what happens in T3?
Turn around.
Turn around. And what happens between T3 and T4?
Accelerate to the negative.
accelerates in the negative direction, then between T4 and T5,
Does
it's supposed to
accelerate.
be horizontal.
It's not going to accelerate.
It's moving with a constant velocity in the negative direction. Then what happens here?
Slowing down
It's slowing down, and at T6
and grounding.
it stops.
Like,
It stops. Makes sense how to analyze what happened with the motion looking at the graph. Now, do you remember what are the relation between displacement and velocity time graph?
under the graph, under the.
The displacement is the area under the graph. Displacement is the area under the graph. So let's say this will be V1 and this will be V2. So, and let's say area of this shape A1, area of this A2. What shape is this? Trapezium. How we finding the area of the trapezium? Yes.
Let's go.
So A1
At this.
will be equal, what this interval, to make it easier, I'll put numbers here, so we will put this will be, let's say, 5, 10, that will be, so this is, and this will be, let's say, 10 meters per second. This is in seconds. So this is, it is from 10 to 0. Let's say this will be 12. T4 will be 13. And this will be, let's say that will be 16, and that will be 18 seconds. Now, I have not put value here. Can we work it out? Can we find what the value, what will be this velocity in the negative direction?
Yes.
Using this formula. We have, what the initial velocity here? 10. So we have 10. Now, what is acceleration? Can we work out the gradient of this part?
Yeah. 5.
We have rise is negative 10 over 2 negative 5. So we have 10 minus 5t, and from this point, when for 1 second, it's moving in negative direction. What will be its velocity here?
5.
Negative 5. So it will be negative 5. Does everyone understand how we work out that this will be negative 5?
Not really.
No. So we found the gradient, the acceleration as a gradient. So it's acceleration negative 5. Now from here to here, 12 seconds, 13 seconds. So for 1 second, velocity at this point is 0. For 1 second, it's moving the negative acceleration with acceleration 5, negative 5. What will be velocity? Negative 5. Make sense? Okay, so area 1 will be this equals 5, this base equals 12, 5 plus 12, divided by 2 times height 10. So what that will be equal?
Where'd you get 5 and 12?
This is 5,
Oh, sorry.
this is 12 bases, height is 10. So what this will be equal?
85.
Yes, correct. 85 meters. Now let's find area 2. Let's find area 2.
We have meters squared.
Yeah, it's meters squared.
No,
No.
it is, we have meters per second times seconds. Meters per second times second. Meters per, we have meters per second on this axis, seconds on this.
You're working out displacement.
Seconds and seconds. cancels out, we go to meters. Displacement is meters, it's not area of the geometrical shape. It's not, if it will be meters, yes, but you have meters per second times second will be meters. So, what will be equal area to? We have bases from 13 to 16, 3. This is from 12 to 18 plus 6 over 2 times 5. So that will be equal. What that will be equal?
9 over 2. 4.5 times 5.
26.5.
22.5, yes. 22.5 meters. Now, what will
A1 minus A2.
now distance? How we'll find distance?
Add the 2.
We need to add 2 because distance. If I move 2 meters this direction, then turn around, move 1 meter back. What distance I travel? 3 meters. 2 plus 1. Distance cannot be negative. Distance is a length of path. So we have distance will be A1 plus A2. So it will be equal 85 plus 22.5 will be equal 107.5 meters. But displacement, we need to take direction to the account. We minus. So displacement will be equal 85 minus 22.5 because this 85 meters in the positive direction and then 22.5 meters backwards. So that will be 62.5 meters. Make sense?
Yep.
And now this you need to really understand because that will be tested on the SAP, on the exam, this type of question. I guarantee that you will, and micro test, yeah, you will have this type of question. So you need to understand what happens here. Any questions? Just all make sense what I did.
Wait, okay.
Yes,
I
sir.
don't really understand how A1 is displacement.
Because area under the velocity time graph is a displacement.
But like why is that what displacement is?
We had discussed it before, so I will repeat. We have, let's say, if we have motion with a constant velocity against time, we're moving with velocity, let's say 3 meters per second for 5 seconds. As a constant velocity, the graph looks like this. So, and if you're moving for 5 seconds with velocity 3 meters per second, what will be our displacement?
15.
15.
Oh, so just
What is the area under this graph?
15.
15. And this meters per second times 7 will give us meters.
Yeah.
So why is it displacement and not distance?
Because velocity is
Because you can move in positive, you can move in negative direction.
And this
What is above, it's motion in the positive direction. If we move in the negative direction, graph is about moving backwards.
yeah, so
So
technically
displacement becomes
If
smaller.
I can't demonstrate for us because it's hard to visualize.
What?
Can you read everything in a positive degree so I can see what actually
I move in the positive 2 meters and then moving 1 meter in the
It's
negative.
not without
You gotta move
acceleration,
85.
it's the acceleration something though, so you actually have to.
What?
Okay, you can do it by yourself, accelerate. Now, one more, the last thing about graphing. What will be if we have graph of the velocity against time looks like this. You start from 0 and moving like this, velocity against time. What will be the graph of the position against time? What will be the graph of the position against time? How it will look like?
So is the position placement or no, distance or displacement? Displacement.
Wouldn't it be the same?
So position is position. What is displacement? Is a change in the position. If we have We started from here
It's the same thing.
and moved, no, same thing, not to here to this, to position 5. Distance 5, displacement 5. Then we turn around and we move to the position -1. What is the distance?
Just 11.
Distance 11, displacement -1. But it's not necessary that position will be equal displacement, because we can start not from 0. If 0 is here, the initial position is 2, we move here up to
It's displacement.
5, and then move here up to -3. First, what will be the distance traveled?
11.
No.
Yes.
Yeah.
3 this way, and 8. Backward is 11. What is the displacement?
-5.
We start -5, yes,
Isn't
very
it
good.
just-
We started at
Position is
2,
-3.
finish at -3, display negative. And what is the position?
-3.
-3. So they all might be different. So, what is the formula? Formula for the motion with the constant acceleration, formula for the position, reminding you x0 plus ut plus at squared on 2. What relationship is between position and time? Quadratic. What the graph of the quadratic? Parabola. So the graph, if you start from the origin, that will be the graph. It will be parabola. Because graph of the position, again, time squared, it's a parabola.
I don't know what triangle is.
Y equals x squared. Don't tell me that you've never seen y
We're
equals
learning
x.
about like right now, like we just started parabolas like.
You've already started doing problems in
Yeah. We did that at the same time last year.
Yeah.
No, in year 9, you're supposed to know about them in year 9.
Yeah, but not wide.
Not master.
Okay, so that is how the graph looks
Did
like.
we do parabolas last year?
Now,
We did problems.
question.
Let me do it, right?
Can you tell me,
So.
can you please tell me what happens with the object if the graph will looks like this? What happens with the motions when x against t
Negative
looks?
acceleration.
It will be with the motion with the negative acceleration. Parabola will be upside down. If a will be negative, this acceleration positive, this is acceleration negative. This is acceleration negative. Okay, that's all about the graph in motion with the constant acceleration. Please like, subscribe, and donate to help Ukraine fight Russian invasion.